we're going to talk about using properties of exponents to simplify an expression. So what that really means is we're going to take something like this that looks really messy with multiple numbers, multiple x's, lots of different exponents, and simplify it or make it look a lot more basic, not quite as complicated. How do we do that? These are the rules that you need to follow. So first, each base must occur only once. That means we don't want to have multiple x's in our expression or multiple y's, multiple numbers, unless you have a plus sign somewhere. No powers should be raised to powers. So that example that I showed you had, squares, fourth powers raised to the sixth power. So we don't want that in our final answer. We don't want parentheses, so we're going to get rid of that whole overall parentheses. In general, in this class, I don't like parentheses, so get used to trying to get rid of them. And last, most importantly, is we don't want any negative exponents or zero exponents. I personally will rarely give you the zero exponent one because it's so basic that it doesn't show me that you know how to do a lot of these other manipulations, but just you do need to know this property, this rule, so it will come up in your homework. I do plan to give you a lot of negative exponents because that rule is applied a lot in chemistry and a few other times throughout the semester. So just get used to negatives are bad. Okay, so how do I actually do all this, deal with all these things? How do I get the base to occur only one time? Here are the actual rules. If you have x to a number times x to a number, you can rewrite that as just one single x, and you would add the exponents, a plus b. So when you're multiplying here, multiplying only, you can add your exponents. Same idea if you're dividing, a fraction is dividing, x to the a power divided by x to the b power. You can write that as one single x, and you would subtract their exponents. If I write it like this, it implies that x is on the top of the fraction. We don't always write over 1. Actually, we never write over 1 when you're writing your final answers, but sometimes it helps people to see, keep it in fraction form. So you can write it this way, a minus b, but you can also say b minus a from this original fraction. But if you do b minus a, you need to keep it on the bottom and just put a 1 on top for your placeholder. So know that if you have a fraction, you can subtract your exponents. It doesn't really matter which one comes first, whether you do a minus b or b minus a. But if you do a minus b, move your x to the top because the a was on top. If you do b minus a, move your x to the bottom because b was on bottom. Hopefully that doesn't overcomplicate it. That'll come up again in examples 4 and 5. So see examples 4 and 5 for a little bit of clarification on this one. Okay, so that's how you get rid of when you have a base that occurs more than one time. I don't know. There we go. No powers should be raised to powers. So how do you get rid of that? A double exponent here. That'd be something like this. X to the a power raised to the b power. You would multiply a times b. Simple enough. But these are really easy to get mixed up when you're adding and when you're multiplying. So gotta have this down pat. If you practice it a lot, then it makes it a little bit easier to be muscle memory. All right, how do you get rid of parentheses? If you were only multiplying or dividing, you can distribute. So I can distribute that a and make it x to the a power and y to the a power, or I can distribute that a and make it x to the a power over y to the a power. Then I get rid of my parentheses. They're not needed anymore because the a has been distributed. If this was x plus y to the a power, you cannot distribute. No, no, no. People try and do that through the entire semester. You cannot do that. It's wrong. Instead, you would have to write this as x plus y times x plus y times x plus y, whatever a is, however many times a is, and FOIL it all out, which is a huge mess. So we're not going to be doing that right now, but note that it will come up later in this semester. I'm going to stick to 2s and 3s here so it's not too intense though. All right, last rule. This one's going to be on your test multiple times. I really like to make sure you know how to deal with negative exponents. But first, how do you deal with zero exponents? Anything to the 0 power is 1. So x to the 0 power is 1, negative 23 to the 0 power is 1, positive 500 million thousand, I don't think that's really a number, but whatever number you can think of, whatever symbols you want to think to the 0 power is 1. Okay, but the more important one that I want you to know is how to deal with negative exponents. So, x to the negative a. I used this trick earlier, or I wrote it as a weird fraction earlier. Hopefully I didn't confuse you, but you can turn anything into a fraction by writing it over 1. We're going to use that trick a lot in here. And so, when you have a negative exponent, think of it as your x is unhappy, so it needs to move in order to be happy and positive again. So, since this x is on top of my fraction and it's unhappy, move it to the bottom of your fraction to make it happy. And you just leave a 1 there, kind of as a placeholder. Same idea happens on the bottom. If you have a negative exponent in the denominator of your fraction, x is unhappy, so it needs to move in order to be happy again, positive again. So x to the negative a is in the denominator. That means x to the positive a would be in the numerator on top. So when you have a negative exponent, you just move it either from top to bottom or bottom to top. Let's do some examples. I have 10 of them for us to go through. All right. Simplify. That's all we're doing for these all 10 examples. So the first example seems pretty simple. 6 times x to the negative 2 power. It looks like it's already simplified, but let's look at our rules again. Each base must occur only once. Well, we have a 6 here, and we have an x here. Okay, a number and a letter. Check. No powers raised to powers. I don't have any double powers here. Check. No parentheses. It's pretty obvious there aren't parentheses in this first example. No negative exponents. That's going to be, every time it's going to be on your test. Well, not every time, but it's definitely going to be on your test because I like to test you on this to check whether you know how to deal with negative exponents. Okay, so just the x is raised to a negative 2 power, not the 6. It's 6 times x to the negative 2. That means I only want to move the x. Remember, if you're negative, you need to move in order to be positive. So that means the x needs to move from the top of the fraction to the bottom of the fraction in order to be positive and happy. Now, we're done. It's simplified. Second example, here's how you can tell when the 6 is raised to the negative exponent. These parentheses here imply that I need to distribute this negative 2 to both pieces, make it a 6 to the negative 2 and an x to the negative 2. So both of those things are happening. Both of them are unhappy now, which means both of them need to move. They're both on top of the fraction. Anything, if you don't see a fraction there, that's implying that it's on top of the fraction. So I need to move my 6 squared to the bottom and my x squared to the bottom. Put a 1 on top as a placeholder. I don't have this written as any of our rules here, but I guess we need to add it somehow. Don't leave any numbered squareds or numbers to an exponent. What I mean here is 6 squared, you should know that is 36. So let's go on and simplify it, make it a little more basic, and write it as its actual number. So let's add that as a 5th rule here. No numbers to exponents. What I mean is actually square it out, cube it out. I can't think of the right word, but multiply it out. Example 3. Let's simplify. I see a negative exponent. I also see multiple x's. And that's about it. No double powers, no parentheses. So you can choose to either move your negative exponent to the bottom first, or I like to go on and combine my bases here, because sometimes when you combine them, it ends up getting rid of your negative. X to the a times x to the b equals x to the a plus b. We are going to add these two together. Negative 5 plus 3 is negative 2. Now I have a negative exponent that I need to move. My 6 and my y squared stay on top of my negative exponent, needs to go on bottom. Make sure you make it clear that that is a x squared and not some weird x2 thing. Be a little clear with your notation. All right, next example. We don't have any negative exponents. I want you to be clear, this is a negative 6. This is just a negative number, not a negative exponent. So I don't have to move the 6 at all. Don't deal with the negative 6. But I have multiple y's. So I want to write my y's only once. We're going to use this rule here. All right, I'm going to make it 5 minus 3. 5 minus 3 is 2. The 5 was on top, so the 2 is going to stay on top of my fraction. I don't need to write a fraction anymore because there's nothing in the bottom, and that's it. What's the difference between example 4 and example 5 other than the fact that I decided to write my y's differently? Is the 5 is on top here and the 5 is on bottom here. So there's two different ways you can do this. I would probably just say, let's combine these. Let's do 5 minus 3 to be 2 again. 5 is on the bottom, so y squared is on the bottom. If you don't like that way, then you could say, treat it just like we did before. 3 minus 5 is negative 2. Now I have a negative exponent, so my y is unhappy because the y has the negative exponent, which means you need to bring it to the denominator to make it happy. So it doesn't matter which way you do it. If you do 3 minus 5, the 3's on top, so make the negative 2 be on top, and then you have to move your negative. Or if you do 5 minus 3, the 5 is on bottom, so the squared will be on bottom. Okay, next example. We have a lot of x's, and then we also have double base for our numbers here. Just think of numbers themselves as a base. You know, you have x's, you have y's, and then you have numbers. So I want to combine these numbers here, or simplify them if you can. Sometimes you can't get rid of the fraction itself, but in this case, 12 over 6 is just 2. I left the x's as they were. And now you can try and combine all these x's all at once. You can deal with just the negatives first and then try and combine them, or you can do it a little bit at a time. I am going to just do it a little bit at a time because I like to chunk things out. It's a little too much for me to do a lot at once. So first, let me combine these two. I'm going to add them together. Negative 2 plus 4 is 2. Oh, that's an x. All right, now I'm going to combine these two, or actually, I don't like dealing with subtracting negatives. Some people like to and go for it, do it. You don't have to do anything the same way I do as long as you're doing something that's mathematically correct. So you could go on and combine these two x's by subtracting 2 minus negative 3, means 2 plus 3. Or I'm going to first move that negative to the top because I hate negative numbers. So when I bring it to the top of the fraction, there's no longer a fraction, so I don't have to write the fraction bar. If you want to still write over 1, that's okay too. And then it'll make it a little bit easier for you to see. Let's combine these two. So I am going to add them together and get x to the 5th. Okay, a few more examples. if I can find my work. Let's get a little more difficult. All right, example 7. We have parentheses here. So the first thing you want to do is get rid of your parentheses before you try and deal with anything else. So to get rid of my 3, my parentheses here, I have to distribute my cubed to all 3 of these pieces. And to get rid of my second parentheses, I have to distribute my squared to all 3 of these pieces. I don't think I'm going to have enough space. Okay, so this would be 2 cubed x, you multiply 6 times 3. Y, you multiply 2 times 3. The fact that there are parentheses here implies that we're going to be multiplying this set of parentheses times this one. So I'm going to put a multiplying. And then distribute your squared. So 4 squared, you can go on and write 16 if you want to. And x, there's an implied 1. 1 times 2 is 2. Or just distribute your 2. Okay, I am going to deal with this first. Oh, these are huge numbers. I need a calculator. All right, 2 to the 3rd power is 8. 4 squared is 16. Now I have multiple bases going on. I have numbers occurring multiple times, and I have x's occurring multiple times. I'm going to deal with the numbers first because I will get confused otherwise and try and make that 8 or 16 some kind of weird exponent or something. So this is 128, 8x to the 18, y to the 6, x squared. So I combined these two together. Next, I have multiple x's, so I want to combine these two together. I will add your exponents. And that's your final answer. I don't have multiple bases, I don't have negative exponents, I don't have parentheses, and I don't have double exponents. Done. All right, example 8. Let's get rid of our parentheses. So distribute my -1 to all of the pieces there. So that means I have 4 to the -1, x, -2 times -1 is +2, and 5 to the -1. I don't like negative exponents. You could try and combine these, but 4/5 isn't going to simplify at all. So I'm going to end up actually having 2 numbers here, a 4 on top and a 5 on bottom. But actually, I do want to get rid of the negative exponents. So I'm going to move my negative exponents. So the 4 is going to come to the bottom. And you can write your 1, or you can leave it off because everything is implied to be to the +1 power. The 5 comes to the top. And the x stays as it is. I would actually write it like this, but I will accept this answer too. And yeah, I do have multiple bases because I have, if you consider numbers just a base, but you can't simplify this fraction at all, so leave it as it is. All right, number 9 is the hardest example that we are going to do because there's a lot going on. If I made this a -6, it would make it even more difficult. You don't have to do it the same way I do it. You can go in whatever order you want to. Like, you may want to try and combine your 2 and 4, make that 1/2, combine your x's and combine your y's before you distribute the 6. That probably keeps it from being such big numbers. But I'm a creature of habit, so I'm going to just always start by distributing my exponent. So the 6 is going there and everywhere down here. 2 to the 6, x. Multiply. Then for my y, multiply. Ooh, these are huge numbers. On the bottom, 4 to the 6. Ooh, multiply. Should have made that 1/2, but we're going to just keep trucking along because we already did it, so we're going to just do it. I'm going to get rid of these exponents here. So what is 2 to the 6th power? 64. Make sure you don't drop any kind of negative as you're doing this. 4 to the 6th power is 4,096. Okay, let's simplify that. 64 over 4,096 is 1 over 64. Okay, I'm going to move my -18 and then I can combine my x's together. You don't have to necessarily do this step. And now I'll combine these x's, which means I'll add them together. You don't have to do every single thing in one step at a time. If you can combine steps, go for it. I tend to mess up if I try and do a lot of things at once. So I'm going to do it one step at a time. And then last, let's combine my y's. 24 minus 12 is 12. The 24 was on top, so the y to the 12 is going to stay on top. And here's my final answer. So that was a lot of work, a lot of steps. Probably should have simplified from the beginning before I distributed my 6, but you know what? It worked out. So there you go. And last example looks crazy complicated, just like the last one. There's lots going on. Negative exponents, there's parentheses, there's lots of numbers, but this is a 0. We haven't used that rule yet. And I don't use it a lot because it's so basic, but people do tend to forget it, including myself until I became a math teacher. So don't forget it. Star it somewhere, put it on your cheat sheet. Remember, anything raised to the 0 power is just 1. No matter how complicated it looks, it's just 1.